Hello, everyone. My name is Doan Kang, and today I'm going to walk you through our exploration of one of the most fascinating materials in the world, aerogel. Aerogel are truly remarkable for their unique properties and wide range of applications. So, my presentation today, I'm going to show you five different parts of aerogel, including introduction, aerogel's properties, manufacturing process of aerogel, four different kind of aerogels and its applications. So first of all, what is aerogel? Aerogels are the world's lightest solid materials composed of up to 99.98% air by volume. The term aerogel does not refer to a particular substance, but more like a geometry that a substance can take on. So over here, you can see there are three pictures. They are all aerogel's pictures, but you can see that they are having different color, different texture, different shape. So why is that? It is because they are made from different material. They can be made from various materials, including silica, carbon, organic polymers, biological polymers, most of the transitional metal oxide, for example, like iron oxide, most of the lanthanide and actinide metal oxide, several main groups of metal oxide, semiconductors, nanostructures, carbon nanostructures, and metals such as coppers and gold. So let's take a closer look at the properties of aerogel, starting with silica aerogel. So aerogels hold records for different special properties. For silica aerogel, they are known for their incredibly low density, thermal conductivities, and optical index of refraction. They are also unique in the speed of sound through a materials and dielectric constant. For carbon aerogel, on the other hand, boast the highest specific surface area for monolithic materials. This makes them incredibly useful in applications where a high surface area is required, such as in energy storage devices. Now let's move to the manufacturing process of how to make an aerogel. So an aerogel starts their life out at a gel, physically similar to jello, which we eat. A gel is created by mixing a solvent with a precursor material such as silica or carbon and a catalyst of Karlslinger if needed. The mixture then undergoes a gelation process to form a solid network around the precursor particle. After that, it will go over the supercritical drying, which is a very common method used to remove the solvent out of the mixture without collapsing the solid structure. The gel is exposed to conditions above its critical temperatures and pressure, allowing the solvent to be removed without surface tension effects. As you can see in the pictures over here, this is the step to make an aerogel. And after the supercritical drying process, an aerogel will be formed. So now let's move to a very interesting part where I will introduce you to some different types of aerogel. There are several types of aerogels, including silica, oxides, metals, and fluoride aerogels. But today I will just walk you through three most common types of aerogel, which are silica aerogel, polymers aerogel, and carbon aerogel. So those are the pictures of the three kinds of aerogel that I just named. Although they are all aerogel, the textures and structures and shape are different. So first of all, silica aerogel. Silica aerogels are composed of nanoparticles of silica, making them highly transparent with a characteristic blue cast. They also exhibit the lowest thermal conductivities of any solid known. Depending on the density of the aerogel, the feeling that the silica aerogel brings may be different. For example, low density silica aerogel will give you a feeling of very spongy in between a styrofoam peanut and a green floral potting form, but not swishy and instead fracturing when squeezed. A medium density will give you a feeling of very pretty much similar to the above, but with the mechanical strength and consistency between a piece rigid, so it may feel like Rice crispy. And on the other hand, a high density will give you a feeling of almost exactly like astronaut ice cream in consistency, but more drier. And a fun fact about silica aerogels is that they are particularly easy to attach chemicals to the surface of their skeletons because of all the silicone groups on their surfaces. So this is a feature that can be useful to make waterproof silica. And over here, you can see in the is the pictures of the 3D models of a silica aerogel. Now let's move on to the next kind of aerogel, with this polymer aerogel. So polymer aerogel made from various polymers such as resorcinol formaldehyde or polyurethane. Resorcinol formaldehyde aerogel are the most researched organic aerogel. And they are really lightweight, flexible, and have good thermal and acoustic installation properties. So right here, the pictures over here you can see is the 3D models of resorcinol formaldehyde aerogel. The resorcinol formaldehyde aerogels is made through a sol-gel process, starting with a solution containing small molecule with the ability to link together to form larger molecular cluster that can eventually grow into nanoparticles, form a continuous network of interconnected nanoparticles that span the volume of the liquid solutions, namely a gel. So in the videos right here, you can see the complete 3D structures of the RF aerogel. And in the case of RF aerogel, the chemistry that is used is the polymerization of resorcinol with formaldehyde in water. Over the course of about 24 hours at room temperature, polymer chains of resorcinol formaldehyde polymer will form throughout the solution, tangling up into RF nanoparticle. And finally is carbon aerogel. This is a very interesting material, which are composed of nanoparticles of carbon with diameters of approximately 1 to 2 nanometers. They have a large surface areas and are electrically conductive, making them very useful in a variety of applications. So the process of making a carbon aerogels is by heating up polymer aerogel to high temperature, which is around 400 to 1800 degrees Celsius in around 3 to 10 hours in an inert atmosphere to make a carbon aerogel. And finally, we will go to the application part of aerogel. Aerogel have a wide range of applications due to their unique properties. They are used in different fields, such as biomedical, aerospace, construction, and chemical. So, in biomedical application, they can be used in tissue engineering to make biosensor. So, for example, carbon aerogel can be used to make carbon biosensor due to their high surface areas and biocompatibilities. And also, they can be used to make drug delivery system. In this case, polymer aerogels is the materials that is used in drug delivery system due to the high porosity and ability to encapsulate drugs. In the aerospace industry, aerogel are used in structural components and interior materials. Silica aerogels are used in insulations for spacecraft to protect against extreme temperatures. Moving to the construction field, aerogels are used as thermal insulator and lightweight materials. They are also used in soundproofing materials. And finally, in the chemical industry, aerogel are used as catalyst supports, absorbents, and infiltration processes. So, in conclusion, aerogel are truly remarkable materials with a wide range of applications. From their incredibly low density to their thermal insulation properties, aerogel have the potential to revolutionize many industries. And thank you so much for listening. That's just my presentation about aerogel and its application.